Hello, algebra students. I'm going to go ahead and go over this Chapter 4 test review, hopefully to help you be prepared for our test next class. So first couple of problems, solve each system below using the method of your choice. And it says show all of your work and upload to Schoology. So first one, you're going to decide, do you want to use substitution or do you want to use elimination? So in this one, I'm noticing that we have that x is equal to 13 plus y. So that means in this other equation, in place of x, I'm going to substitute in 13 plus y. So I'm going to have 4 times, and I'm going to put this in parentheses, 13 plus y, and then plus 2y equals 10. So in place of that x, I put in this 13 plus y. Then what we want to do is we want to distribute this 4. So I'm going to have 52 plus 4y plus 2y equals 10. I can add these two together. So I have 52 plus 6y equals 10. I'm going to subtract the 52 from both sides. So I have 6y equals negative 42. And then when I divide by 6, I get that y equals negative 7. All right, so now that I know that y equals negative 7, in either of these original equations, I'm going to substitute negative 7 in for y. I want to find x, so I'm going to go ahead and substitute it into this equation here. So this becomes x equals 13 plus negative 7. So that means x is equal to 6. We want to write our ordered pair, our answer as an ordered pair. So we don't want to have to search all over your paper to figure out where your answer is. You're going to write your answer as an ordered pair xy. So 6 comma negative 7 would be your answer for number 1. For number 2, looking at that, there it's already lined up the x's, the y's, and then the constants and the equal signs. And I notice I have a 0 pair in front of the x's. So I'm going to go ahead and use elimination. I'm going to add my equations. So this would be 0x or just 0. Negative 12y plus 7y is a negative 5y. And then negative 40 plus 30 is negative 10. I would divide both sides by negative 5. So then y is 2. If I know that y is 2, in either one, it doesn't matter which, in either one of these equations in place of y, I'm going to substitute in 2. I could do it here or I could do it here. I think I'm going to pick the first equation though. It really doesn't matter though. I'm going to pick the first one. So if I pick the first one, I would have 16x minus 12 times 2 equals negative 40. So again, in place of the y, I put in that y value of 2. So then I have 16x minus 24 equals negative 40. And then I'm going to add 24 to both sides. So I'm going to have 16x equals negative 16. And then when I divide both sides by 16, I get x is negative 1. Again, I want to write my final answer as an ordered pair. So my ordered pair here would be xy, so negative 1, 2, in parentheses. Otherwise, it's just a list of numbers. It should be in parentheses. Okay, so for 3 and 4, it says write, do not solve a system of equations to represent each problem below. So first one, Ethan's football team scored a total of 35 separate times this season with a mix of touchdowns and field goals. Each touchdown is worth 7 points. Each field goal is worth 3 points. If the team scored a total of 193 points this season, how many touchdowns and how many field goals did they score? Usually this last bit here will tell you what you're looking for, and that gives you a clue about what your variables could be. So what I want to know is the number of touchdowns and the number of field goals. So I could say I'm going to let t equal the number of touchdowns, and then I could let f equal the number of field goals. Now I want to write an equation. I want to write two equations using the information that I'm given. So I'm noticing up here that I'm given some information about the number of points scored, and then I'm given some information about how many times they scored. So they scored a total of 35 separate times this season. And then they also tell me with a mix of touchdowns and field goals, each touchdown is worth 7 points. So now I'm given information about points. Each field goal is worth 3 points, and they made a total of 193 points. So I'm going to use that information now to write my equations. So the total of 35 separate times, that was a combination of field goals and touchdowns. So I could write an equation that the number of touchdowns plus the number of field goals equaled 35. And then each touchdown is 7 points. So 7 times each touchdown plus 3 times each field goal gave us a total of 193 points. So you kind of want to group like things. So here, everything having to do with score here and everything having to do with like quantity here. All right, so this next one, Emma went to the movie theater for her birthday. A mix of adults and children attended, making a total of 19 people. Each adult ticket was $9. Each child ticket was $5.50. The total cost of the party was $150. How many adult and children attended? So again, this last part here is giving me a hint about what my variables should be. So I'm going to let, let's say, A equal the number of adults. You could also use X and Y if you want. And then I'm going to let C equal the number of children. And then again, I'm going to look back. I see I've got some information about money, and then I got some information about how the total number of people that are attending. So they're telling me that, let's see, a mix of children and adults attended, making a total of 19 people. So, and that's made up of children and adults. So that's going to give me one equation. And then they're giving me information about money, right? Adult tickets are $9, children tickets are $5.50, and the total cost of the party was $150. So that's where my two equations are going to come from. So a total of the adults and children. So adults plus children, there were 19 people. I know adult tickets were $9, so 9 times however many adults plus $5.50 times however many children totaled $150. So then those are my two equations. Okay, again, you didn't have to solve these. All right, moving on to number 5. A system of equations is graphed below. These two lines are parallel. What is the solution to the system? So the solution is where the lines intersect. Since the lines do not intersect, there is no solution. Okay, so since the lines do not intersect, there is no solution. All right, number 6, a system of equations is graphed. These two lines are coinciding. That means that they coincide. One is right on top of the other. It's the same line. What is the solution to this system? Okay, so if you have one line and then on top of it you put another line and you're trying to think, okay, well, how many places do they intersect? They intersect at every single point. So that means there are infinitely many solutions. So since the lines are one on top of the other, they intersect at infinitely many points. So there are infinitely many solutions. All right. So then let's take a look at this next one, 7 and 8. So simplify each expression. Make sure there are no parentheses, zero exponents, or negative exponents in your answer. All right, so this first one, I'm multiplying these, and then here I'm dividing. So when I'm multiplying, really, you can think of it as almost having like little dots in between each of these. It's like I have 12 times a to the 6th times b to the 7th times c to the, think of that as to the first, and then times 10 times b to the first times c to the 11th. So then if you wanted to, you could rewrite it as 12 times 10 and then group the like bases together. So a to the 6th, and then think of it as b to the 7th times bring this b, and then times c to the first, and times c to the 11th. You don't really have to rewrite it that way, but that's really what is happening. So I'm multiplying my constant, so that's 120. I've got an a to the 6th. When I multiply these b's with the same base, remember you add the exponent, so that's 8. 7 and 1 is 8. And then with the c's, 1 and 11 is 12. And then that is our final answer. All right, when it comes to dividing, I'm going to divide things with like bases. So I'm going to divide my x's. This is an x to the first. And then I'm going to divide my things with a base of y. Remember, the rule when you're dividing is that you will subtract the exponents. So that will be x to the 16 minus 1 is 15. And then y to the 5 minus 3 is 2. There are no negative exponents, so we're good to go. All right, number 9, what is the solution to the system of equations graphed? And then how do you know? Remember, a solution is where the lines intersect. They intersect right there. So my solution is the ordered pair at which they intersect. So pay attention to the scale here, because this is -1 right here. So I go to the left, -1, I go down -2. So my solution is at -1, -2, because that's where the lines intersect. Should have probably typed this. My handwriting is terrible right now. All right, and then the last one, solve following equation. All right, this has fractions. I hate fractions. So the trick to get rid of fractions is to look at the denominators and figure out basically the common denominator, and then multiply through the entire equation by that value. So I see they both have a 3. So what I'm going to do is I'm going to multiply the entire equation through by 3. Everything, even if it doesn't have a fraction, everything's going to get multiplied by 3. So 3 times 2/3 x, I'll write that out if that helps. Well, that would just be 2x. And then 3 times 7, so minus 21. That's times, not a decimal. And then 3 times 1/3 x, that's just 1x. Plus, I have to do 3 times 3, which is 9. And then I'm going to solve that resulting equation. I was just highlighting where all those 3's came from. It came from just that distributing. All right, so what do I think? I think I would subtract this 1x. And then I would say I have 1x, or just x minus 21 equals 9. And then I would add 21 and have the x equals 30. All right, so make sure that you come to support if you have other questions about this review.